So what do you think we do as like a first step for applications? We're going to draw it out. We're going to label it as best as we can. And then do the same thing. Sometimes it might be a double triangle. Sometimes it might just be a single one, which this first one is just single, but you'll notice that it's different if you start reading through it. So let's take a look at what we have. Two planes leave an airport at the same time. The first plane flies at 200 kilometers an hour on a bearing of 150 degrees. Second one flies faster, 360, at a different bearing. How far apart are the planes 2.5 hours later? This is one of the types of questions that we're going to do. Some of the questions will be a little bit different. You'll have to think through. We're doing 3 together today that are kind of a particular type. And this is a good one that you want to kind of recognize what type it is. So it's giving us speeds and bearings, and it's a particular type. You need to draw it a particular way. Does anybody remember doing these in grade 10? Vaguely remember what to do at all, really? Okay, let's see if we can figure it out. So first of all, we're going to do this. We're going to draw with our ruler. Across. Like that. This is kind of like a northeast, southwest cross. I didn't draw it symmetrically on purpose, but the northeast, southwest part, it doesn't tell us north or whatever, so we don't really need to worry about that. But we're going to start with this, okay? Then we're going to draw 150 degrees. So that's going to be like this. Doesn't have to be perfect. I'm going to make mine close, but okay. So I've got that line, and that's 150 degrees from here. They're on the same, their bearing always starts from the same place. So if I start one of them 150 degrees from here, the next one, which is going to be 245, is also going to start from the same place. Okay. So the other one is going to end up over here. And again, you don't have to be perfect. It's going to be something like this. And this person's flying faster, so what do we know about them? In 2.5 hours. What do you think? 200 kilometers an hour for 2.5 hours, 360 kilometers an hour for 2.5 hours. What do you think?
The first plane traveled 500 kilometers.
And what about the second? Okay, so Zach calculated it, but think about this in general. They flew for the same amount of time. The second plane was flying faster, so it's going to fly farther. Does that make sense? It will help when you draw your triangles that you have some idea of which line is longer than which line. Okay? And then it says, how far apart are the planes 2.5 hours later? So I am going to connect these two lines. And that is what I'm going to solve for. Zach, how did you find those numbers?
This distance by time.
So 200 kilometers an hour times 2.5 hours gives you 500 kilometers. So that's this one. And 360 kilometers an hour times 2.5 hours is 900 kilometers. You can't put speeds here. That's not going to work. So we need these distances because we're calculating the distance between them. So I need those distances. And that's why this is a particular type of question, because drawing it out like this is a little bit different. And figuring out the distances is a little bit different. And you wouldn't have to do this, but I don't know, maybe you want to redraw. And relabel. Try to draw it more or less the same. So this is D. This is 900 kilometers. And this is 500 kilometers. What do I need to find D? Because we're not given it directly, but we can solve it with the stuff that we have done. I'm missing one measurement here. Zach?
You need the angle in between 900 and 500.
So how am I going to find that? Sarah, do you know how to find that? Yeah. So 150 takes me to there. 245 takes me to there. So the difference between them is this, which is 245 minus 150, which I think you'll find is 95 degrees. And then what am I going to use? So again, applications, it's all about getting them set up, understanding the information you're giving, drawing it so you can visualize it, labeling it correctly, maybe solving for an extra angle like that. But now that I've written it like this is just like a question that we were doing last week. So which one is it, sine law or cosine law? It's definitely not SOHCAHTOA. Brooke, do you know? Why? Very nice. Two sides and the angle between. So D, and we're solving for a side length. So we're going to use this one. Cosine of the angle between them. And I got 1066.98. It doesn't say what to round to. Usually the questions will. This one happens not to. Again, who knows why they need to know this? Maybe there's a reason why they need to know it really accurately, but I would think that rounding to the nearest kilometer is probably good enough. Therefore, the planes are 1,067 kilometers apart. So our steps were we drew it out on this cross so that we could see the 150 and the 245. So we found our distances so we could draw a proper triangle. Then, and you don't have to draw it twice, as long as your first diagram is not too mucked up and you can kind of see where everything is. Then we figure out what we're doing to solve, and these questions are all similar when we're doing this kind. Solve and state our answer. So this one's another very particular type. From his apartment window, the angle of elevation to the top of the apartment building, that is 100 meters away from Stewart's, is 35. The angle of depression to the bottom of the building is 43. How tall is the apartment building? So we've got a couple things happening here. We've got this term angle of elevation, which you probably recognize. We've got this term angle of depression, which is harder for people to remember how to do that. And we're given the distance between them, and we're given those two angles. We have to draw the proper diagram, and then there's a couple of different ways that we can do it. So I'm going to start by drawing Stewart's building. Come on in. That's right. Okay, and I'm going to say Stewart is just somewhere in the middle. And it says the angle of elevation to the top of a building is 35 degrees. Again, you don't have to be super accurate with this. Don't worry too much about that. Actually, it's going to be more. 35. And then the angle to the bottom is going to be 43. And this is the other building. Okay, so I want to show you something. The distance between them, when I draw it in here, so put your pencil down and watch. Angle of elevation and angle of depression always start from a horizontal. You never draw it from the vertical. So the angle of elevation, what does elevate mean? It's going up. So I go up. And that was 35 degrees. And what does depress mean? Like down. So you're pressing a button down or something like that. So the angle of depression always starts, this, people have a hard time with this one. You're going to see this in the next example. Always starts from the horizontal and goes down. And that one is 43. And then the distance between them is 100. And now I have my diagram. Any questions about that? So we got a couple of triangles, and what are we calculating? We're calculating the height of the building, which goes from the top to the bottom. So we're looking for that, height of the building. Can anybody think of how you might solve this question? There's a couple of ways that you could do it. What do you think? Yeah. Yeah. So what would I find in this top triangle? I've already got 100, so this top one or the side one? The side one, and what about the bottom one? And then what would you do? So we could do that, right? And that would be fine. Some of these questions you can do multiple ways. I'm going to do this one a different way. But you could find, and both of them would be tan. So I would find x here and y here, and then add them together. Can anybody see the other way that you could do this question? Sarah, do you think? No? Looked like you might have an idea. What do you think?
You can solve it as a full triangle and use cosine law if you sum of the two angles in if you add them.
So what if we do add them? What's 35 plus 43? 78. So that's definitely 78. So yes, I have an angle inside this triangle. These are both right angles, by the way. Right? So what we can do is I can find this. But you do it whichever way makes sense to you. But let's see, because I think everybody can visualize the other one. So let's try this one because it's a bit different. So let's find x first. So for x, we're going to use SOHCAHTOA. And I've got 35 and the angle adjacent, or the side length adjacent to it, which is 100. And I'm finding the hypotenuse. So this is going to be cosine of 35 is equal to 100 over x. That. And what do I do here? How do I rearrange this? Pearson, what do you think? Very nice. And remember, we're going to calculate this and we're going to keep it on our calculator as best as we can. So I got 120, and I'm going to write down extra digits, 0775. Now how can I find h? So don't copy this down, but now I have something like this. Okay, and I know this is 122 approximately, and I know this is 78, and I'm looking for that. So what do I need to find h? An angle. Can we find an angle? How? Yeah, so in here I've got this 90-degree angle, and I've got this 43. So to find this one, I subtract from 180, and that gives me 47. So in this triangle now I have 47. And which one is this, sine law or cosine law? Jada, what do you think? Sine law, because I've got a side length and an angle across from it. And I'm looking for that one. Very nice. Side length over the sine of the angle across from it, which is sine of 78, equals the side length I got, which is the 122.1, over the sine of the angle across from it, which is 47. Now, I've still got that 122.0074589 stored on my calculator, so I'm just going to go answer times sine 78, close bracket, divided by sine 47. And I got 163.3 meters. Which way do you like better? Just using SOHCAHTOA and adding, or like that?
I feel like using SOHCAHTOA is easier.
Yeah?
But I don't really mind.
Yeah. Do you find it fewer steps? That's interesting, because I didn't think it was, because you'd have to add at the end, like you're doing two things here anyway. I mean, you're finding a couple of extra angles, but you have to add them together at the end. To me, they're about the same length, and it's just how you see it. I think it's important to understand that a lot of questions can, and if you do it right, you better get the exact same answer. But yeah, you can absolutely solve it the way that you feel most comfortable. All right, last one. This is another one that can be solved two ways, I think, and we've seen one similar to this before, but it wasn't exactly the same. Wasn't in applications, I don't think. Okay, so whoops. Let me get rid of that for a second. From the top of a lighthouse that is 25 meters above the water below. So the top of the lighthouse is 25 meters above the water. The angle of depression to a boat is 65 degrees. So we're going to start by drawing a lighthouse. And it is 25 meters tall. I'm also just going to kind of draw the water out. So then I've got the angle of the depression to a boat is 65. Certainly does not have to be exact, but. And then to a boat that's further out is 48. And here's what people do, and it's wrong. So put your pencil down and watch. They put the 65 here and the 48 here. Why is that wrong? Because we know it was an angle from up at the top, right? And those are the triangles, so why would that be wrong? What do you think?
I'm not sure why it's wrong, but I know you have to use it to like put a line at the top and then the angle goes there.
So remember what I just said, angle of depression and angle of elevation both always start at a horizontal. Always, always, always. I gotta undo those, get rid of those, because they are wrong. So you're exactly right. We are going to put a line up across the top. And again, just watch for a minute. This is the 65-degree angle. and this is the 48. They're not inside the triangles. That's why everybody struggles with these kinds of questions. And there's a couple of different ways that we can use those to get the angles we need. But you got to make sure you draw it correctly. If you label your 65 and your 48 inside there, I mean, it's wrong. You'll get part marks for other stuff, but that's not where they go. Angle of depression questions are always tricky, unless you really think about it. Got to start at a horizontal and measure down. Does anybody know how I can get these angles into the triangle? It's not hard. There's a couple ways you can do it. Some people, one of them is visual, and it just makes sense. For some people, they might just memorize. Jada, what do you think? Very nice. So the top line here and the bottom line are parallel, which means it's the Z pattern. And you can just memorize. That means the 65, I'm going to go along the top, down the 65, and then along the bottom. That means this one is also 65. And you can kind of just remember that. It's 65 up there, but it's also 65 down here. And I do the same thing. I come along here. I go down the 48 and then back along. And that means this one is 48 degrees. And now I have the ones that I need. What's the other way that I could have used those angles? Anybody know? Well, this is 90. So if this is 65, what is this little bit? 90 minus 65. So that's going to be 25 degrees there. And do the same thing for this one. So I could get this angle and I could get this angle. But having those ones is enough. And then, we haven't done this yet, how far apart are the boats? So what we're actually looking for is this distance. Now we have to figure out how we're going to solve it. Anybody have an idea? Sarah? So find this with SOHCAHTOA and? Yep. Good. So we could do, so same thing, we could use SOHCAHTOA. Guess what? We can also use non-right triangle stuff, and we're gonna do that one. You can do the other one if you want, but I'm gonna do this one. And to do that, I'm gonna find this length instead. I'm gonna find x. So that one's still SOHCAHTOA. I'm using 65. Opposite of 65 is the 25, and x is the hypotenuse. So this is sine. When I punch that into my calculator, I get 27.5844. And now I have a triangle like this. Let's see if this works. Nice. Okay, and this is the D that I'm trying to find. This is the 27.6, and this is 48. What do I need in order to solve for D? And can we get the angle at the top? Ellie?
Couldn't you 180 take away, was it 40?
48? 180 minus 48 won't work, but you're on the right track. 65 minus 48, I think, is the easy way to do it, because this angle, take away this, will give us what's left over. So this is 65 minus 48. And that works out to 17. So this is 17 degrees. Yes?
But couldn't we do 48, 180 take away 48, and then do 180 take away, then we had those two angles, and 180 take away those two angles gives us.
It's definitely possible that you could do it a different way. I think you'd have to have I think you'd have to find other angles in order to do it that way. But you, and well, you can't subtract from 180. If they're all together, yes. So hold on. If you've got a straight line and you've got this angle and you've got this one's like 40 and this one's, I don't know, 30, you can subtract those two from 180 to get that. That's a different situation than we have though, because we've got 65 and 48 is part of the 65. They're not on opposite sides of each other. So it's a little bit different. Oh, you mean I could find this one?
Yeah, and then with those two angles.
Yeah, so like I say, there's definitely other ways that you can do it, yes. So we could find this angle down here and then subtract those two from 180, and that would give us 17 as well, absolutely. That would be two steps, this was one, but same thing, yeah, for sure. Okay, now we can finish this for D. So we are going to be using sine law again. So I've got D over the sine of the angle across from it, which is 17, equals the 27.6 over the sine of the angle across from it, which is the 48. And I got 10.9.